resume recording here real quick. Forgot to do that. So, oh, hang on. Let me just stop for a second. Hunter, is the PowerPoint uploaded on D2L? That's a good question. You know what? Let me, I don't know. Let me just check for a second, Hunter. Has anybody else got that issue? Is unable to find the PowerPoint?
I don't see it either.
Okay, well, you know what? That's my bad. I can resolve that. Boy, that is my bad. I apologize. Give me 1 sec. Sleepyhead slattery here. Oh, let's see. This will take me less than a minute to quickly upload it, depending on the speed of D2L. Okay, thanks, Hunter, for that. Appreciate that. Again, my apologies. I always load this up ahead of time. Yeah, deforestation is pretty quiet. Okay, let me quickly upload the file here, and then I'll get back to the material in just a second. And let's see. I have a very sleepy computer at the time where I don't want a sleepy computer. Okay, deforestation is getting loaded right now. And there it is. Hunter, thanks. I appreciate that. Let me get right back to getting that online, changing the display setting here. And maybe we're back online. Okay. All right. Yeah, thanks, Ben. Okay. So the material's up there, should be up there. So, yeah, this is the drive up to Monteverde. And Monteverde in Costa Rica sits right up here, the top right section. And the reason why I always start this material with this slide is that it reminds me, and certainly for the students who go on this trip in Costa Rica, it gives them a real sense, I think, for the first time about human impact on forests and what our landscapes could look like as opposed to what they in many ways should look like. And what I mean by that is when you look in the front part of this diagram here, all of these areas that are without trees are areas that have been deforested, largely for grazing and for cattle. And even though this is the rainy season where things are pretty green, when things get dry, that landscape looks certainly not as appealing, and you start seeing things like runoff and erosion, as opposed to another hour and a half along the drive when we get up to the top right-hand corner of this diagram, and you move into the Monteverde cloud forest, which is one of these remarkable tropical rainforests, called a cloud forest because it's at an elevation where the trees spend a long time in the clouds, right? And you can see that in this photograph. And it's a landscape that always makes a very strong impression upon the students, where they see human impact in one area and pristine reserve in another. So, when we look at a human impact on the surface of the earth, folks, I've made this point several times as we go through this material. We have transformed our landscape, right? We've transformed our land through urbanization, through agriculture, and certainly mechanized agriculture. And this is a generalized map that shows the level of human disturbance. Now, I know this is a scale that is explained in detail in a paper that goes beyond the scope of this course, but I use this just to draw your attention to the areas that are in red and purple, where you see very high levels of human disturbance. So, for example, when you look at the United States, kind of west of the Mississippi, there's lots of agriculture, industry, and so on. When you look at parts of Europe, of course, there's been huge levels of disturbance through urbanization and agriculture. India is a very agricultural part of the world. The point, quite simply, is that we have dramatically disturbed our landscapes, right? Don't mistake the Sahara for a forest, right? Green is just simply indicating very little levels of disturbance. And so our focus here today and for the next little while is going to be on these areas where we have had a change in in surface cover. So we're going to focus in here on the Amazon, right? We're certainly going to focus on tropical regions, rightly or wrongly, and I'll explain why we look at tropical regions. But forests are one of our great resources, and they're also one of the resources that are under, greatest threat. 40% of our ice-free land has been transformed into agricultural land alone, right? So clearly that's important. We need to feed people, but we also are changing ecosystems and changing habitat as a result of that. So those are the connections that I want you to start thinking about, and that I hope we're able to make over the next couple of lectures. Now, one of the other important aspects here, everybody, when it comes to forests is what they do for us, right? I like to think about forest systems as something that we call system regulators, okay? So what does that mean? What does a system regulator mean? Well, what forests do is they provide a whole host of services free of charge. So when you look at the left-hand side here, and this is just a simple graphic that I try to come up with to illustrate a couple of the important points of forests and what they do, right? When you have an intact forest, one is that vegetation, that organic material protects the surface from rain, it protects the surface from soil erosion, it binds the soil, it's healthy, it keeps the organisms and the nutrient cycling. But of course, when you cut down that forest and you expose that soil to rainfall, much more of that water can end up causing soil erosion, degrading the soil, and so on, right? So forests are, and especially tropical forests, are absolutely critical, not just as habitat for species and not just to provide wood, but as ecosystem services and system regulators. They regulate the climate, they regulate the hydrologic cycle, they of course provide oxygen, and so on, and they do this all free of charge, right? So I hope that makes sense as just another reason why we should protect them. Okay, so let's start here. So this diagram is, this image shows forest canopy heights in meters. It's a very high resolution image taken from a number of different satellites that have been put together. And so the darker the color here, the taller the forest. So just take a minute here to look at this and kind of get a sense as to where the tallest and by extension the most connected and arguably the most important forests reside, right? So when you look at this, you can see, I think, or get a sense as to why we focus initially on the tropics. So I'm just going to draw a line here, right, and through here, and going down here into Asia and Southeast Asia. So these are the tropics, right? The tropics generally lie between 23 to 25 to maybe 30 degrees north or south of the equator. The equator will run somewhere through here, right? So these are the great tropical forests of the world, the tropical rainforests. And, you know, rightly or wrongly, we're going to focus on those because those are ecologically the most important. They are the forests that house the greater number of species. But before I go any further, I really do want to make the point and make the comment that these forests over here around the rest of the world, so the temperate deciduous forests of North America or the coniferous forests of Siberia and Canada are equally important, right? But we will focus on tropical rainforests because that is where most of the deforestation is occurring, and that is where most of the human impact and the impact on species and soils is occurring. So let me stop there and see if there are any questions in there. Anybody got any comments about the map of forests? You can see the canopy heights, they're taller, they're denser right throughout the great Central African forest, the Democratic Republic of Congo, obviously the Amazon, and the rainforests of Indonesia, Malaysia, and the island of Borneo, and so on. Everybody good? Okay. All right, so let's start with the bad news, okay? So this diagram here shows annual deforestation in the Brazilian Amazon, right? And I'm going to start with the Brazilian Amazon because that is where arguably most of the attention has been and it's certainly one of, if not the most dynamic forest systems that we have. So what are we looking at here? Okay, so this graph shows a couple of things. So it shows the annual rates of deforestation. On the left axis here is the annual loss of forests in square kilometers, right? And folks, this is the Brazilian Amazon. This is just in Brazil. The Amazon also includes other countries, northern parts of Paraguay and so on, but we're just focusing in on the Brazilian Amazon here. And so these vertical bars show the annual rates of deforestation relating to the left axis, annual forest loss. And this line here, the red line with the diamonds, relates to the right-hand axis over here. And those diamonds show the percent of the Amazon remaining relative to 1970, right? So this is 1985, and if we go back all the way to the left here, we'll find 1970, it's not shown. So it just shows the percent of the Amazon remaining relative to the 1970 cover. So someone talked to me about this diagram, and it goes through to 2019, and I'll update this in just a second. What do you see? What are some of the key concepts you can take away from deforestation in the Brazilian Amazon?
From 1985 to 1988, I mean, it remains like constant, like that for like 4 years, and then we have a dip, and then we have a large increase in 1995, right. Dip all the way down, and then large increase up to 2005, and then we go extremely down to 2009. Cool. Remains average and consistent.
Okay, cool, Gavin. So I'll summarize that by saying there's a whole bunch of variability here, right? So I'm glad you actually made this comment. It's not that deforestation was exactly consistent from 85 to 88. These are estimates. There's some uncertainty in these estimates from the Brazilian satellites, right? So we have deforestation goes down. We have some extremely high years here, but from 2004 onwards, right, things start looking very good, relatively speaking, so that by the time we get to 2012, okay, there has been about a 65 to 68% decrease in the deforestation rates from here to here, right? So that's obviously great news. And in the early 2010s, the Brazilian government really was very proud, and I think justifiably proud, of the decrease in deforestation. We're going to look at why this is all going on in just a minute. So I agree with you, good observations. But then in 2012, things start getting a little tricky, and it looks like we start increasing again, right? Up to 2019. If I just update the latest data I can get my fingers on, okay, from August 2019 through to July 2020, we've seen an increase by almost 10%. Brazilian deforestation is once again on the rise, right? This is enormously problematic, and I want to examine why this is going on, what's driving it, and why we should be concerned by this increase. Let me also say, as we go through this chapter, everybody, I'm going to try not to give you too much data, okay? Like, it's very easy to throw around, here's how many thousands of square kilometers was cut down, here's how many thousands of hectares was cut down. In a sense, that those are just numbers that kind of wash over people. It's like, okay, what does that really mean? So I'm going to try and contextualize that as we go through this. So here's one of those contextualizations at the bottom here, right? Since 1970, we've lost the size of Texas in the Brazilian Amazon, right? That may help a little in terms of trying to kind of get your heads around just how much forest we're losing, okay? So that's over 700,000 square kilometers. Texas is almost 700,000 square kilometers, right? So we have cut down an area the size of Texas, which I think is quite extraordinary when you think about it. And this is not forest that's been regrown, right? This is nothing to do with reforestation. This is just tropical forest that has gone, okay? The red line and the diamonds basically show that we have about 80% of the Brazilian rainforest left. In other words, since 1970, we've lost 20%. That's what the size of Texas means. in terms of Brazil. Does that make sense to everybody? Okay, all right.
So what happened in 2012 to make the decrease so great during that time?
Okay, so that's a great question, right? And we'll talk about that. I'm going to put you on hold, Janera. That's a really good question, because that's ultimately the importance of a diagram like this, right? Not just showing you data that goes, oh, here, it's going up, it's going down. What's driving it, right? So a little bit of a giveaway. A lot of this is being done for agriculture and especially for cattle grazing, right? So beef is really big here. Holly puts palm oil. Palm oil is not a big issue in Brazil. We're going to come back and look at palm oil, but I'm glad you put it there, because there are commodities that are driving this. There's government incentives that are driving it. There's illegal deforestation that's driving it, right? But the Brazilian government did put in place in the early 2000s a number of things to reduce deforestation, a moratorium on beef, for example, right, to slow that down. There's also a political overlay to this, Janera, which is not lost, and that is the president that was elected, Jair Bolsonaro, and I can see Josiah's just putting that up in the chat. Yeah, really, really astute observation, right? Bolsonaro was elected, and he was a populist president, very pro business, very pro economy, and has put things in place to encourage deforestation. And you kind of think about that and go, what are you doing, right? Why are we cutting down this precious resource? I'm going to look at that. I'm going to try and unpack the complexity of that, because deforestation is enormously complex. Just a personal anecdote, you know, as I think you folks know, I've spent a lot of time in Costa Rica. I've been there, I don't know, 40 times probably to Costa Rica. Love that country, right? And you see some of the deforestation that has happened there over the recent time. Now, I should say Costa Rica has dramatically turned things around. But you talk to people and you go, you know, why was deforestation so rampant in Costa Rica when the people on the ground knew that cutting down trees was bad? And you go, well, let's see, we're a relatively poor country and people need money. And what's the quickest way to get money? Cut down trees and plant cattle, right? Raise cattle, because beef is such a high-priced commodity, right? So it's a very complicated socioeconomic, geopolitical background to this diagram that you see there. So Janera, thank you for that. I'm glad you asked that. Any other thoughts or comments on this? All right, let's dig a little deeper. We're going to keep unpacking deforestation, right? So here is the Amazon. Okay, this is another one of these. I think this is an absolutely awesome. This is from that big diagram that I showed you of canopy heights. So this shows canopy heights. And I should just point out, yeah, we're going to be talking about the tropical rainforest. So the tropical rainforest is all up here in the Brazilian Amazon. This is one of the most impacted, fragmented, deforested areas in the world. Okay, this is known as the Serra Gorda. It's a sort of tropical savanna. All right, but we're going to just put that aside here. We're going to spend some time looking in the tropical rainforest in the Amazon. And I don't need to annotate this because I've got this here. Let's zone in here in this state in Brazil called Rondônia. Okay, so Rondônia really came to the public's attention in, I suppose, the 1980s, when deforestation was beginning to become rampant, right? Okay, so let me just stop here. There's an interesting question from Sandy here. Since we know the trees are good for the environment, why are countries in the world not replanting as we're depleting the forest? So that's a good point. So many are, right? And many are not. And so Sandy, hang in there a second. I'm going to come and try and answer that as we begin to look at what's driving this, all right? So yeah, you know, so for example, let me just make a quick comment. In the United States and Russia, we cut down trees, right? We use a lot of trees, but we also replant through reforestation. So we've got to look at deforestation versus reforestation and whether there's a net loss. Here I'm just talking strictly about net loss, right? Deforestation. So I'll come back and address that, Sandy. Circle back if I don't. Good point. So let's look in at this area here called Rondônia, right? Okay, so this is a part of Rondônia. And anything in brown here shows deforested areas, okay? Anything in green is trees. What do you notice? There's something quite unique going on here. This is deforestation in the Brazilian state of Rondônia. Incidentally, this is 1985.
So to me, it slowly looks like from the left side where it says Nova Memore and the right side where it says, I'm not even gonna try. They're like slowly creeping in together to meet. So it's like slowly happening.
Okay, so what's that called? If you've been good people and read the chapter ahead of time. There's something weird going on here, right? You can see it here as well. Okay, what I mean by that is they haven't come in here and carved out a big fat square of forest, okay? This is a pattern of deforestation that emerged in the Brazilian Amazon and was, it's not, it is no longer just unique to the Brazilian Amazon, but it was unique to the Brazilian Amazon. Okay, anybody want to have a guess what's going on?
It's called fishbone pattern.
Good, Laurel, keep going.
I don't quite remember, but I know it's like a certain pattern that like helps with access or something. I don't know.
No, good, okay, good. So, yeah, so Christian has put that in fishbone pattern. So I don't know if any of you have been right in the heart of a tropical rainforest, right? It's pretty tough going to move through a tropical rainforest. You got to have an access road. So here's an access road going into the forest, right? Once you get access into a forest, whether that's a legal road, an illegal road made by loggers or whatever, then people can get in there, okay? And people who get in there are largely what we call shifting cultivators or subsistence farmers, right? These are not farmers going in there and setting up large commercial farms to start growing pineapples to sell to market. They are subsistence farmers, right? Poor people, one, who don't own the land, and then two, go in there and they cut out a patch of land, 2 to 3 hectares. Now, a hectare, so 1 hectare, and the abbreviation is HA, 1 hectare is basically the same as 2 football fields. So think of 2 Amon Carter football fields, right? Minus the end zones, but don't panic about that. So they go in and they take out about 6 or so, on average, football fields. And they'll cut out a hectare, they'll cut down the vegetation, right? And what that is called is slashing. So they'll slash the vegetation, then they'll burn the vegetation, right? To try and get those nutrients into the soil quickly. And then they'll plant short-term cash crops or short-term crops to feed their families. So you've probably heard of slash and burn, right? Or shifting cultivation or subsistence cultivation. Another term for that is swidden. It all means the same thing, right? So they'll go in there, they'll clear out a hectare, and that will produce a crop for a year or two, and then the soil dries up, the nutrients go away. So guess what they do? They go and take another hectare, and another hectare, and another hectare. And they start going into the forest like this, cutting down hectare after hectare, burning the forest, and then planting crops. And when the soil dies, they then cut off another hectare and another hectare like that. Everybody see that, right? So this is known as developing the fishbone or the herringbone pattern of deforestation. So you can see it here. This would be the main bone of the fish, okay? And here are the bones. This is what a mahi-mahi or a red snapper might look like once you've demolished it on the plate, right? Does that make sense to everybody? Okay. So these are shifting agriculturalists, swidden agriculturalists. They're poor people and they're planting crops to either get cash in the short term or simply keep their families alive. And it leads to this very unique pattern of deforestation called the fishbone pattern. So look what happens here. This is 1985. This is 10 years later, right? I mean, you can't argue with photographs or satellite images, right? I'll go back. You know, keep an eye on this area here, pristine rainforest, okay, 10 years later, right? And so this is a pattern that starts emerging in Brazil, and it's been emerging in other parts of the world as well, for sure, all right? And I'm not insinuating that the fishbone pattern is the only way forests are cleared. They're not. But here's the problem, right? The problem is that this pattern of deforestation is extremely destructive, right? And it's much more destructive actually than going in and clearing out a square area. Let's say you come in here and just clear out this patch of forest. So let's say this is now a cleared patch of forest, right? And let's say that this patch of forest is an area that is 10 miles by 10 miles. I'm just making this up. So you come in here and you're interested in cutting down the trees here and putting up a farm, right? So this is now cleared forest. How much forest have you cleared here in square miles? Oh, math people. What's the area of forest clearance? It is 10 by 10.
100 square miles.
There you go. It's 100 square miles.
Sorry,
So
I
we
had
don't-
like my chat on like the chat window open and I was trying to unmute and I couldn't.
Okay. Yeah, no, it's not a trick question, right? So there's 100 square miles of forest that you've cleared. Okay. The area of forest that you've really disturbed is this, right? The boundary between the cleared area and the undisturbed forest, right? That's the edge of the forest, right? And that edge in how many miles, how many linear miles is 40 miles of edge of forest boundary. Does that make sense? Right? Simple math. Okay. That's a very disturbed area where species are crossing over from trees into no tree, trees into no tree, right? But look what happens when you go into this part of the forest over here. Okay. If you clear an area here, and let's say you clear an area, this area here, let's say all of this cleared forest equals 40 square miles. I'm sorry, 100 square miles, right? All of this cleared patch adds up to 100 square miles of forest cleared, the same amount that's cleared here. But the boundary, the disturbed area, what we call the edge effects, is much greater, right? The edge effects are all of these linear edges along this fishbone, right there and in there, and right there and in there, right? Does everybody see that? Your linear boundary could be hundreds of miles, okay? So the fishbone pattern of deforestation, this shifting agriculture, fragments the forest much more dramatically, okay? And it fragments it because the edge effects are much greater in the fishbone than in the non-fishbone. Now, don't get me wrong, everybody. I'm not saying it's absolutely awesome to come in here and clear 100 square miles of forests, right? I'm not saying that. I am saying that this is a much more disturbing way of doing it. Kind of like doing a jigsaw puzzle, okay? During COVID, my wife and I had the most exciting 6 months of doing these 3,000, 4,000, 5,000 piece jigsaw puzzles, okay, as we tried to get through this isolation. And it's like taking 1,000 piece jigsaw puzzles and taking 100 pieces out of the center, or randomly taking 100 pieces out over the entire jigsaw puzzle, right? You fragment the jigsaw puzzle much more by doing that, if that makes sense. That means you disturb the soils, you disturb the species and so on. So there's an interesting question that's popped up here by Josiah. Are there ways to revitalize the said soil? Yeah, that's a great question, right? There is, if you leave that patch for at least, well, the science says at least 2 decades, right? Okay, because what happens, and this is the another interesting part, is when you look at this tropical forest here, right? And I'm gonna spend a bit more time on this lecture than I probably would want to, but this is really key. When you look at this forest here, Josiah and everybody, this is supporting a rich tropical rainforest. A lot of people think that the soils underneath here, right, are themselves very, very rich in nutrients. Doesn't that make sense? Lots of big trees, lots of species diversity. The soils should be rich and diverse. Exactly the opposite is true, right? The soils that sit under tropical rainforests are actually very nutrient poor. Why? One, all the nutrients, or almost all the nutrients, are cycled at the surface by the vegetation and all of the nitrogen and stuff getting taken up at the surface. All right. So the nutrient cycling is very, very rapid in the forest. And the other point is that if you clear a forest, right, those nutrients get washed away very quickly by the very high amounts of rainfall. Okay. So there seems like this oxymoron in tropical forests where you have very, very diverse and rich vegetation versus you compare the soils in the Midwest. So if anyone's from Iowa or Nebraska, the soils in Iowa and Nebraska are richer in organic material and they're richer in nutrients because those nutrients can decompose and accumulate much more slowly in the soils. So getting back to Josiah's question are there ways to revitalize the soil? If you go in there and you plant year after year, those nutrients disappear and the soil becomes essentially useless, right? Question from Vin, why don't they cut into the leftover green area too? They are, right? That's the point, Vin. This just shows areas from 1985. So there's 1985. Let me just click back here a second. So here's 1985, right? Here's 1995. If I would overlay the 2010, you would see most of this area is gone, okay, in terms of deforestation. Let me stop there. Questions? I'm going to ask you in the final exam to explain why the herringbone pattern is more destructive than other forms of deforestation. Take it to the bank. You're going to see it. Oh, Vin, I mean the green patches between the bones. Eventually they will. Eventually they merge, right? Absolutely they do. They merge.
I don't know if this is like necessarily relevant, but like what kind of like products and stuff are being made out of like, or what is like this like the end goal of deforestation?
Okay, it's completely relevant. Yeah, great question, Betty. Hold on to that if you wouldn't mind.
Okay.
Because we'll get there, right? So deforestation, I want to get through what's happening, and then I want to get to why it's happening, right? So the quick giveaway, Betty, is we talk about the agents of deforestation, right? What's driving it, right? The direct agents and the indirect agents of deforestation. And the question of who's doing it is important. And then the question of why are they doing it and what products are they getting out of it? So hang on to that thought. It's a key question, because if once we unpack that, then we can only start talking about what are the possible solutions, right?
Yeah.
Okay, cool. Good question. Okay, a little bit more data just to keep you on your tippy toes here, right? And again, I'm going to try and give you not just numbers, but geographic context here. So this shows, so what's been going on lately, right? This shows, and I've taken all of this data from the United Nations, the Worldwide Forest Assessment. This shows the average annual tropical primary forest loss worldwide. Okay, so there's a new term there, primary. What does primary mean? Primary means forest that has never been disturbed by humans, okay? Secondary forests are forests where you've cut down the forest and then it's regrown. So for example, when we walk through some of the forests in Costa Rica, you can tell which is a primary and which is a secondary by the height and the degree of growth. Sometimes you can't because the forest grows so quickly, right? So primary is untouched, secondary is forest that is regrown. These data are tropical primary forest loss worldwide. Look at the global average, okay, from 2001 to 2013. That's about 13 million hectares per year. From 2014 to 2018, in other words, that 5-year period, it's averaging 4.3 million hectares per year, right? Around the world. This is not just Brazil. This is tropical primary forest loss around the world, okay? That's an area equivalent to the size of Denmark, okay? And you're probably going, all right, well, that's cool. I've never been to Denmark, right? Well, if you've never been to Denmark, that's equivalent to 8 million Amon Carter fields. 8 million Amon Carters, right? That's absolutely extraordinary. I mean, that's extraordinary, okay? That's equivalent to looking at, and I've tried to bring this a little closer to home on the bottom right here. This is a Google Earth image. Here at the top here, you can see this red circle. At the top here, that's going into Oklahoma. At the bottom there, that's going down to those, I think they're national basketball champions. I can't mention the name, but they're down south of I-35, okay? and you can see that circle west or east here, that's the size of Denmark. That's how much tropical primary forest we're losing every year, at least in the last 5 years, right? It's mind-blowing, okay? And I'm aware of not trying to be overly dramatic when it comes to tropical forest loss, but it truly is extraordinary how much forest we're losing, okay? If you're not convinced, let's look at not just tropical primary, let's look at the big picture, right? How much tropical forests are we losing worldwide? Totally, okay? We're losing, this is 2018, we lost in 2018 around the world an area the size of Pennsylvania. Folks, I'm never going to ask you in an exam, how many million acres of forest are we losing? How many million hectares? That's not my point here, right? The point is to give you a sense of the scale of the issue, right? And these are the top 10 countries, okay? And I've kept the units the same. It may look a little funny here. So these are thousands of hectares, and this is 1,347 thousands of hectares, right? That's how the United Nations reports them, okay? That is the same as saying 1.3 million hectares, okay? That's one. So Brazil is lost in 2018, 1.3 million hectares, followed by the Democratic Republic of Congo, Indonesia, Colombia, and so on, right? So absolutely, Brazil leads the way still in terms of tropical forest loss, okay? Does that make sense, what I'm showing here? So the top one is the total forest loss around the world in the tropics. This excludes anything outside of the tropics. The bottom graph here just shows the top 10 countries in terms of the absolute amount of forest that's being lost. When you look at the countries in terms of losing forest as a percentage, right? So this is the top 10 countries losing the most tropical primary forest as a percent change from 2017. These percentages just blow my mind, right? Ghana, the Ivory Coast, right, on Africa, and you look at other countries here, Liberia, Tanzania, the Democratic Republic of Congo. Ghana lost 60% of its forest in a year. Again, I'm going to come back and address both Holly's and Betty's questions about what's driving this, what's this going on, right? I'm just trying to give you a sense of the scale. None of this is sustainable globally, clearly, when you start losing forest at this rate, right? It's pretty extraordinary. The link back to chapter 6 is this, okay? So this is a diagram that I've come up with. It's a bit of a complicated one. I'm not going to ask you to do this in the exam, but I want to make sure that we're tying in this material to climate change, right? Because remember with the carbon cycle, I said we're putting 9.5 billion tons of carbon into the atmosphere from the emission of fossil fuels, and we're putting in 1.6 billion tons of carbon into the atmosphere from deforestation. This diagram makes that link explicitly, right, as you look at this. So what this diagram shows is, let me just change colors here, is the change, right, in the average CO2 emissions, the change in the CO2 emissions from deforestation between 2002 to 2013 and 2014 to 2018. So what does the numbers mean here? Let me just point out the big one here, right? So Sierra Leone on the west coast of Africa, that is a 473% increase. The scale here is, this is 100 to 200. This is anything over 200. In other words, the deforestation in Sierra Leone has shown a 470+% increase in CO2 emissions from accelerated deforestation in the last 5 years relative to those first 12 to 13 years, right? Anything in red, right? Democratic Republic of Congo, India, Chad. These are 100 to 200% increases in carbon being added to the atmosphere as a result of deforestation, right? And lo and behold, where is most of the problem, right? We come back to the tropics here, okay? Places like the US, yes, we cut down a lot of trees. Canada, we cut down a lot of trees, but we replant those, okay? Through reforestation, the comment that I think Sandy made earlier on, okay? that make sense, what we're showing here? So I'm just trying to make the link here between deforestation and climate a little more specifically. All right, a couple of other, sorry, question? Janira.
Sorry.
So
So
go ahead.
when we look at these charts, are we assuming that this is primary or secondary?
Great question. This is everything. Good question. This is all of it. Yeah, probably should put that on the. Janira, I'm glad you asked that. It's complicated when you look at forest data, because you do have to ask that question. Are we talking about primary and secondary? Are we talking about tropical or deciduous? You know what I mean? You've got to set the forest loss numbers in context. Yeah, this is everything. This is all of it. Okay, here's a part of the world that we're going to come and talk about a little bit when it comes to Chapter 8 and biodiversity. I have not been here. I don't know if anyone has been to Madagascar, right? Made famous in the movie. Madagascar is such a unique and interesting place and is an incredibly important place when it comes to species diversity, right? This shows the extent of Madagascar's forests in 1950, and you can see across the top here relative to 2005, okay? On the bottom right is a space shuttle photograph of Madagascar where you can see that kind of spine of trees running up the eastern side of the country. On the bottom left is a photograph from the central mountains of Madagascar, where everything has been chopped down and you see these land scars and features of erosion, right? Something like 10% of Madagascar's forests remain. And again, we're going to come back and look at why that is the case, right? I just simply want to make the point that some parts of the world that are ecologically very important are being devastated. So this is a general map. We take a step back here to try and summarize this. And this shows global forest cover. Janira, this is everything, primary, secondary. And it's an estimate based on kind of our current understanding of what was the original forest cover, sort of pre-human settlement, to where we currently are now, right? So there you can see Madagascar. I'll just point that out there. Madagascar was once, at least this is what all the archaeological and the paleontological evidence suggests, Madagascar was once completely forested, totally forested. We have 10% left, right? You can see the Amazon, right, has lost a lot of its forest over here. This doesn't look dramatic, but this all here represents that 20%. So yeah, there's a lot left, okay? But look at this. This is just catastrophic, okay? And of course, Western Europe was once all forested, but we cut that down through. So that all means something. It means something in terms of resources, and it certainly means something in terms of species. So where are we going to go next, right? Which is why I kind of putting the questions from Holly, Betty, and others on hold, is we're going to look at why, right? We're going to look at what is driving deforestation, right? And when I say next, I'm not going to do this morning. I'm going to round that up and talk about what's driving deforestation, both in terms of what we sometimes call the agents, in other words, who's doing it, and then the commodities and the underlying sort of socioeconomic principles behind that, which we'll come back to next week. So it'll be about a 20-minute wrap-up of deforestation, and then we'll make the link between forests and species. So any questions, anybody, on the material before I stop the recording and hang around for general chat? All makes sense, all good. All right, awesome. So that's an introduction to deforestation. We'll pick that up and continue on Tuesday. Have a great weekend.